My name is Andrew McLean. I'm an agriculture customer lead for the Bureau of Meteorology. I'm based in Melbourne. I should make clear at the outset that I'm not a meteorologist. My background's in land and natural resource management, so I bring that perspective to the Bureau. Today, I want to cover this scope. So that is a quick introduction to the Bureau's engagement with the agriculture sector through the agriculture team that I'm a member of. Then I thought it'd be useful for us to take a quick look back at the spring weather in South Australia and then look forward to the long-range forecast for the next 3 months. Then I want to explain and outline the changes the Bureau is making to the way we communicate the long-range forecast. And I'd like to take the opportunity to brief you about how to make the most of those forecasts, and including a walk through our website if I can make that work. Could I encourage you to ask any questions that you may have or make any comment that you have via our agriculture@bom.gov.au email. We love to hear from producers and we promise to get back to you as soon as we can. So why are we here? The Bureau's aligned itself with the agriculture sector's target of achieving $100 billion of gross value of production by 2030. That's a target that's clear and straightforward and provides a framework for the Bureau's contribution. So by providing forecasts and other services, the Bureau aims to help producers mitigate risk and to seize opportunities when making weather-dependent decisions. So the Bureau's got a small agriculture team. It's within what's called our business solutions group. And each of us in the team have backgrounds in relation to agriculture and resource management that's relevant to the Bureau's support for the agriculture sector. In a lot of ways, the agriculture team represents the agriculture sector within the Bureau. We engage with and listen to the sector, and we ensure that our colleagues are aware of issues and concerns. Almost all the work we do is in partnership with agricultural organisations. Let's move on to talking about the weather. So spring in South Australia, you've all been through it, so perhaps I'm telling you stuff that you already know. But if you look at this map of rainfall deciles, it shows a really contrasting situation across South Australia. I guess it's a big state, so perhaps contrast is inevitable. But we saw above average rainfall across most of the north of the state. You can see how that extends into Western Australia, which had a very, very wet spring. It's highest on record, if I recall correctly. But in the southeast and the central districts, rainfall was below average. And this continues the pattern, and I know I'm not telling you anything you don't know, but this continues the pattern of low rainfall that you've experienced during winter. And we know at the Bureau that South Australian producers have certainly had a really tough year. I think your neighbours in Western Victoria would share that experience. I haven't bothered to map this, but spring maximum and minimum temperatures were above average across the entire state. But despite those high minimum temperatures, severe frosts in mid-September did a lot of damage to grain crops. Keith fell to minus 4.6 degrees, which was a record low for November, and at minus 0.4 degrees, Cleve experienced its lowest minimum on record. So that, adding to the dry season, was another blow really to that sector. Moving on to the summer outlook. Now, this is hot off the press. This was issued only an hour or two ago. We issue these forecasts once a week. So you can see that the outlook for the rest of summer is that Queensland, New South Wales and Western Australia can expect higher than average rainfall for the season. But in this outlook, which was different to last week, South Australia has a moderate to high chance that rainfall will exceed the long-term average in the south and the west of the state. Hopefully that's a bit of good news. As I said, this is a significant change towards a higher likelihood of rain since the forecast that was issued last Thursday, and the importance of regularly monitoring these forecasts if they're an important part of your decision making, because they do change from week to week as the models ingest new information. During this period, again, I've not mapped it because it's a boring map, it's all red. It is that temperatures will continue to be warm, with both maximum and minimum temperatures likely to exceed the long-term average for the season across the entire state. I'll be talking more about interpreting this forecast later in my presentation. But now I want to move on to the primary purpose for me being here, which is to talk to you about the improvements we're making to the way we communicate climate information. The headline is that we want to encourage people to focus on the long-range forecasts rather than make predictions or assumptions, perhaps, based on the individual influences like the El Nino Southern Oscillation, often called ENSO. And for this and other reasons, we'll be retiring this ENSO watch dial. Many of you will have seen this. It appears in the media It's been around for more than 10 years. We felt that too much attention was being given to movements on this dial, and that simplistic assumptions were being made about what climate implications follow for the movements of the dial. For the same reason, we will retire the international model summary of ENSO and the other climate influences for the same reason. Now, the long-range forecast keeps up to date with ongoing changes in our climate systems, including all of these climate influences, and integrates them. It considers all the factors, all the influencing factors in the oceans and the atmosphere that affect seasonal weather, rather than just a select few. And that's why we think, certainly at the seasonal scale, our long-range forecasts are a better guide to the climate, the upcoming climate, than the simplistic assumptions we make about El Niños and La Niñas and Indian Ocean dipoles and all the rest. Why are we making this change? A bit more about that. One important reason is feedback from the agriculture sector and the wider community have noted that decisions have been made based on misinterpreted information. We listen closely to those views and share them. It's been a concern of ours for a while, so this is the time to make the change. We're making the change because, as I've said, the climate indicators alone are a less reliable indicator. So sometimes during an active El Niño, another climate influence, the southern annular mode, can lead to increased rainfall in eastern Australia, and we saw that over the last summer. The access model, that's the basis of our long-term forecast, incorporates observations from the ocean, the atmosphere, ice and land, as well as the interactions of the climate influences, rather than just relying on historical data from a single factor like ENSO. So it improves forecast accuracy. And we've seen a shift of the science of meteorology away from statistical models to these dynamical models. And the dynamical models are complex models that use physical principles to model the behaviour of the atmosphere, warm air rises, all that sort of basic stuff that we learned in physics at high school, in a much more sophisticated way is at the fundamental to the model. And we think that they're showing steady improvements in forecast performance, and it's time to go a lot in with the access model. So this timeline just shows you how forecasting has changed over the years. It's 1980 when we first issued a long-range forecast, and now we've been progressively updating our computer capacity and the models themselves. We collaborate with the UK Met Office in particular in regard to access, but we collaborate with international agencies and make sure that the science behind our model is as good as we can make it. I should say, to be clear, the major influences like the ENSO and the Indian Ocean dipole and the southern annular mode are still very important, but access incorporates them into its dynamical model of the climate in the months ahead and models the interactions between them. Here's a couple of examples from last summer. So an El Niño was declared late in 2023. So a lot of people said El Niño, that means we're going to get a hot, dry summer in the east. And that statistically is a valid assumption, but there's more going on. And indeed, as we saw, above median rainfall is possible during the El Niño phase of ENSO. So this is the January 2024 rainfall map, which shows that Eastern Australia received very much above average rainfall across a lot of the east. This was the long-range forecast issued on the 4th of January. It was from a model run on the 1st of January, and it predicted that indeed we would get that wet weather during that month. So the assumption that El Niño leads to a dry season was contradicted firstly by our forecast and then by what eventuated. Another example, perhaps not so powerful, is La Niña. And in 2022, we would have expected a cool and wet season. And indeed, in Victoria and southern South Australia, or across most of southern South Australia, we received below median rainfall. Now, the model's not such a strong predictor of this. The point about this, it was not predicting high rainfall for that region in that season. The access model isn't perfect. It has hits and misses. You can see that this forecast didn't pick up the heavy rainfall in northeast Queensland, but overall, on average, it's a better bet than simple assumptions about La Niña being wet. Here's some more information. You may have seen these maps have been published for a few years now, which correlate the rainfall received over the continent, annual rainfall in this case, over the continent with El Niño and La Niña and neutral years. And here's just a few examples. So in 1976, it was an El Niño year, but Eastern Australia was quite wet. 2008 was a La Niña year, but much of southern Australia was dry. 2007 was similar. And 2018 was a neutral year, but was very dry over most of the country. I'll say again, it's not to say that the correlation between annual rainfall and ENSO doesn't hold. There are certainly years like 1975 and 2010 to 2011 where the impacts of La Nina in those cases were very evident. But at a seasonal scale, I'll say again, our advice is that the seasonal forecasts will generally be a more reliable predictor than assumptions about the ENSO. Okay, so if we're going to ask you to rely on those long-range forecasts, we better talk to you about how to make the most of them. These forecasts are the output of a complex model called Access S. It assigns a probability to whether the period ahead will be wetter or drier than the long-term median, and whether maximum and minimum temperatures will be warmer or cooler than the long-term median. And we present the result in a map of the continent, but information is also available down to the 5 kilometre grid scale, and we'll have a look at how that works in a minute. Forecasts for the week and fortnight ahead are issued daily, and for the month and season ahead, they're issued weekly, usually on Thursday afternoon, and as I said, including today, a couple of hours ago. Now, Access is what's called an ensemble forecast, and I just want to divert for a minute to talk to you about what that means. So the Access S models run 99 times to generate a forecast. Because the input data to the model is inevitably uncertain, each run starts with slightly different data. And it runs through the process and ends up with a solution for rainfall and for temperature and all the other parameters that we're interested in. So today's presentation is certainly not about cyclones, but this map of the progression of a cyclone off Western Australia gives a nice visual representation to how an ensemble forecast is made. This example combines multiple international models. Each of the fine lines on the map that you can see is a single ensemble member of one of the models. And as you can see, there's a wide range of possible tracks for the future of this cyclone. It's probably still not quite a cyclone at this stage, but the ensemble models run all over, individual ensembles go all over the place. But as you can also see, there is a clumping of ensemble members heading southwest from the origin. And this provides the basis for our prediction of the future track and strength of the cyclone. The track we forecast is the most likely track, but we also see the uncertainty in the forecast and the spread of those ensemble members. So you'll often see the line of the cyclone's predicted path is in black, and there'll be a sort of an envelope drawn around it, which is an indication of possibilities, perhaps eliminating some of the more extreme examples. On the right, you can see a diagram from the UK Met Office, which is another explanation of how ensemble forecasts work. So hopefully that gives you a sense. To say, we're not talking about cyclones today, but Access is an ensemble forecast. 99 runs are given. Each of them will have their own result, and the forecast we offer, the probabilistic forecast we offer, is a reflection of the spread of those models, spread of those ensemble members, sorry. So let's have a look at a specific example. To access the distribution of those ensemble members, you can search for your location using a button on the top left of the forecast chart. Now, we're going to walk through this shortly, but I'll whiz through the slides first. So you can click on that search button and type in the location you want to search, and basically it knows where you are. It knows where Jamestown is in this example, and will pop up this Outlook graph. This is just for January, and this was what I should stress was issued on the 5th of December, so it's becoming a bit old. The key point about this example from Jamestown for January is that the ensemble members are widely spread. It's changed, as I say, it's changed slightly since, but it's still fairly widely spread. So this is saying that of the 99 ensemble members, 17 of them came out in the unusually dry category. 20 of them came out in the unusually wet category, which is the long-term just statistical likelihood. 51% of members came out above the long-term median. Remember, the probability of above long-term median in any case is only 50. So this is a fairly, what would you call, an uncertain forecast for Jamestown. And we stress this because we need people to be looking at this and understanding this in making decisions about their farm, their enterprise. We don't want people assuming that the forecast is stronger than it is. It's very important that I stress that you should not assume that because the region mapped around Jamestown is white and not green or brown, that you can expect that the rainfall will be about average. That's not the message this forecast is giving you. What it's giving you is the message is that it's about equally likely to be above or below median. And in this case, it's a very even spread. So rainfall is this middle decile, on the middle pair of deciles. As you can see, that's actually the least likely outcome in this distribution. So white does not mean median. White means a wide spread, usually. You can also click on the graph symbol at the top of the pop-up. And again, I'll demonstrate this shortly, and that gives you this graph on the right-hand side of this slide, which is a 5-month outlook. And that's presented as a graph with what's called a box and whisker plots, and the height of that box and whisker plot is an indication of the spread of the models in that particular month, and it's overlaid with a long-term average. And also this one's showing past rainfall, so it's showing that September the rainfall at Jamestown was very low. It was in this brown zone, which is in the lowest 20%, and then it popped up again in November to give a rainfall in the top 20%, and this is the black dotted line as a sort of the median forecast going into the future, which is suggesting that it'll be on the lower side of median over the next 5 months. I want to draw your attention to the star symbols on the two graphs. This provides an indication of the past forecast skill of a model at that location for the forecast period. So you can see here that the past forecast skill has only been low to moderate, 1 to 2 stars. So that's another factor to consider in interpreting the forecast. So it might be a bit disappointing that we don't get a strong signal from the model at Jamestown. So let's look at what a strong signal might look at. So these are two different locations, and I'll chop the top off them because it doesn't matter where they're from. But on the left, you can see a forecast with a strong bias towards a higher than median rainfall. You can see in this case, the model ensemble members of the model have come out, 2% of them have fallen into the unusually wet category. 87% of them are above median, when, as I said before, the long-term above median, the random above median would be 50%. There's only a 5% chance in this model of unusually dry conditions. You could say that it's 10 times as likely to be very wet than very dry. You can also see that the 3 stars indicate that for the unusually dry and median chance of above median forecast, the past forecast skill has been high. But on the right here, you've got a situation a bit like we've just seen at Jamestown. Ensemble members are spread out across multiple possibilities. So this isn't a very strong indicator to what might be happening in the future at this location. We would say this one might be worth betting on a bit. But it is a bet. I was commenting with one of my colleagues yesterday. This is showing we end up using gambling analogies. But if decile 9 and 10 here was a horse in a horse race, you might say that's the favourite. This might be the second favourite, whatever that percentage is, 22%. You wouldn't be amazed if it won. And that's just the nature of these things. What the forecast is this, what eventually we observe may not be what the forecast says. It's just the nature of statistics. What impacts accuracy? We might be a bit frustrated at times about the lack of certainty or skill in our long-range forecasts, but bear in mind that the atmosphere and its interactions with the oceans and the landscape is incredibly complex. So predicting the behaviour of this system months in advance is very ambitious. You can be assured that the Bureau has teams of climate scientists who focus every day on how these models can be improved. So the present limitations, as we're seeing in this Jamestown example, really just reflects the limitations of climate science. It's not like anyone's falling down on the job. These models, the access model is as good as any in the world. The data is put into it and that's what comes out. So there's a few factors embedded in this. One of these is that the model itself, the input data will generate a wide range of outcomes. At certain times of year, the model doesn't perform as well as others. There's a thing in Australia called the autumn predictability barrier, which is unfortunate because that's a time when a lot of important agricultural decisions are made, but it's just the nature of our climate that it's difficult to forecast at that time. Forecasts become less certain on longer lead times. Forecasting tomorrow's weather is a lot more precise than forecasting the weather in a week's time, or a month's time, and 3 months' time. That's just inevitable. Things happen in the atmosphere that we can't predict. A really classic example is small-scale variations like thunderstorms and cyclones can really throw a long-range forecast out. Our long-range forecast, the access model, doesn't do a very good job of picking up cyclones a month or two of the event, and they can be a major source of rainfall. So let's move into a demonstration now. I'm going to take you to the bom.gov.au, navigate you through to find these forecasts. They're not that simple. If you're very clever and you have your phone with you, that's the QR code. That'll take you straight to the Outlooks page. I'm going to give you about 3 seconds to go click, and then I'm going to move to this site. So this is the starting page. To get access, you go to climate and past weather, you go to long range forecasts, and up pops this screen. See a national, if you go to the overview here, you'll see a national overview, and there's a little video presented which walks you through. It's only 5 minutes or so to watch. That's useful to watch for a bit of interpretation. Then we always end up focusing on rainfall, and that's what I'll focus on now. But you'll see that for rainfall, you can get different sorts of maps. I'll walk you through those, and you get different forecast outlooks. So it's 1 week, 2 weeks, 1 month, or 3 months. I think I'll focus on the 3 months. So this is today's forecast for the 3 months. So this first map shows the chance that rainfall will exceed the long-term median for each location across the country. So the median, of course, in northwest Western Australia is different to the median in Victoria. So the map is comparing forecast rainfall with that long-term median and giving a probability that rainfall will exceed the median at each location. You can see that I've been stumped here. I wrote these notes before this forecast was issued. So I'm to explain to you that the outlook for most of South Australia is neutral, but that's actually not the case. This forecast has gone in the right direction if you're hoping for rain. And you can see for a lot of southern South Australia, there's actually a reasonably good chance, like a 60 to 70% chance that we'll see higher rainfall, higher than median rainfall in South Australia. But there's other ways of looking at this forecast, and one of that is to look at the chance of extremes, and that sometimes is a useful separating out some of the noise. So this map, the chance of unusually wet, is saying what's the probability of rain being in that top 20%. So you can see a lot of Queensland or northwest Western Australia, there is a chance of 1.5 to 2 times the normal chance that rainfall will be unusually wet. But we can see there's a chunk of southern South Australia here that's also in that sort of 1.5 to 2 times as likely to get unusually wet, unusually high rainfall in January to March. The unusually dry, I think, is actually the better news. This is showing that nowhere in Australia is there a forecast that more than 1 to 1.5 times as likely that rainfall will be in the lower 20% of records. So that's a source of some comfort and confidence. This map shows you different outlook scenarios. So the 75% chance you'll get at least this much rain. There's a 50% chance you'll get at least this much rain. And if you're really lucky, a 25% chance, the 1 in 4 chance is that you'll get, what's this saying? It's about 50 to 100 millimetres across most of South Australia. So you can make judgments there. And again, we're back to those horse racing analogies to say, well, what's your appetite for risk? Do you want to work on the 50-50 chance, or are you prepared to say, look, I'll take a chance on we getting this 25% outcome? That's a choice only you can make. Another way of looking at it is the chance of at least. You can say, how much rain do I want? I want 25 millimetres, an inch in the old scale, and this is a map that gives you the probability that you'll get that much rain. So it's a fairly low probability, unsurprisingly, up in the Simpson Desert, and a bit higher in the lower southeast. But if you're a bit greedy and you want 200 millimetres, it's going to be a very low probability across all of South Australia. But you can see in the tropics, that chance is quite high because of the wet season. This chance of 3-day totals is actually something that applies only at the 1 week and 2 week horizon. And it's an example of the Bureau responding to advice from the agriculture sector. This product was developed in consultation with the ag sector through a project that ended a couple of years ago called Forewarned is Forearmed. So this is showing you the probability of getting 15 millimetres of rain in 3 days, or 25 millimetres, or 50 millimetres, or 75 millimetres. And as you can see, the party is up in the north at the moment. There's a very low chance of getting a 3-day rainfall burst of 15 millimetres here in South Australia, or in Western Victoria, Western New South Wales. And this final map is simply the, I'll go back to the 3 months, is simply the background climatology. This is in a median year. This is what the distribution of rainfall looks like. But you can look in it and say, what's it look like if it's unusually dry or unusually wet? And I'll move on from there. Another important part of this is the past accuracy of the forecast. So here we're looking at a map that shows a percentage rating of accuracy for issuing the chance of above median forecast. And you can see for most of South Australia, it's sitting at 55%. Which is not terrific, but it's better than 50%, basically. That's the message. And you see a few little patches here and there where it gets up to 55 to 65%. And here up at Exmouth, it's above 75% for picking above median. But there's different metrics for unusually wet and unusually dry. So unusually dry, you'll see some patches that are very low. Again, we need to consider that when you're making judgments about the confidence you can have in that forecast. Okay, now let's go back to the chance above median, and this is one of the really important messages for you. It's this: let's have a look at the location. So I'm a bit bored with Jamestown, so let's go to another location in South Australia. Let's go to Mount Barker. Type that in, click on it. Now there's a little wait. I don't know why there's this little wait here. It just takes a little bit of time. I fear some people say, oh, nothing's happening, and they move on, but up it pops. So here is the distribution of the access model outcomes for January to March at Mount Barker. It's saying 30% chance of unusually wet conditions, the top two deciles. A 14% chance of unusually dry, a 62% chance of it being above median, but low pass forecast skills, so only 54% for median and 53% for unusually wet. So if you're running a property up near Mount Barker, you'd look at that and you'd need to make a judgment about how much confidence you want to have in that January to March forecast. All I can say is that it's better than it was last week, and keep checking it because it could improve or it could get worse. That's important to keep monitoring that. When we click on this graph, remember we get a 4-week forecast and a 5-month forecast. That's showing the past rainfall at Mount Barker and the forecast for the future. So you can see this December forecast is, well, we're nearly finished. I suppose it's nothing to be too proud of, but that's a fairly tight spread of possibilities. January, February, March and April, you can see them spreading out. For reasons unknown to me, the Bureau's decided to call January 7 and February 8. I presume that'll be something we fix up in the next little while. Another bit of information on this is this graph, which is the historical and forecast probability of exceedance. So this is saying that, just picking this random number, that historically there's a 12% chance that Mount Barker will get more than 123.2 millimetres, but the forecast is saying there's a 28% chance that you'll get more than 123.2 millimetres. That's another way of looking at the same data, but remember that star rating. I just wanted to pick a contrasting area. So let's pick one of these bright green spots. You don't need to type in a location if you want. You can just click on the map and wait. So we're up near Georgetown in the Gulf country, Staten, just come out as, and that's showing a 75% chance with high forecast skill. That's 6% of above median rainfall. So that's just making the point here. There's an example where the forecast is biased towards a wet January to March. So that's the long-range forecast. So what I encourage you to do is to find it and have a play with it and ask questions about it. And that agriculture@bong.gov.au is always there. Say, what's this all about? And we'll do our best to answer you. If we can't give you the answer ourselves, we'll consult with our climatologists and meteorologists and try to get the answer for you. We're going okay for time. I'll just finish off with a quick survey of some other forecast products from the Bureau, if that's okay. So I need to change my screen sharing again. And Hannah, what are we seeing now? Are we back to the PowerPoint?
Yes, we're back on the demonstration PowerPoint.
So just quickly go through this. Here's some other forecast products that you can access through the Bureau's website. Australian Water Outlook. I'll go through these as separate examples in a minute. METI, this is the 7-day forecast. It gives you a spatial 7-day forecast and gives you a forecast for every little grid square in the country. We've just been talking about this, the long-range forecast, and this is my climate view, which gives you the outlook to 2070. So METI is a really good, powerful way of looking at what the weather's doing over the next 7 days. You can get a graphical forecast, a map-based forecast, or you can get, if you wish, you can get a text-based forecast. That's that box in the bottom left. You can search for your location, just like I showed you for the long-range forecast. You can click on, in this case, someone's said, let's look at what's going on in Moree in New South Wales. And you'll get that summary of the 7 days. You can click on the detail button on that summary box, and that'll give you a 3-hourly breakdown of what's going on in Moree. Or you can just use that table, which gives you different levels of information. You can look at rainfall on a 3-hourly or daily basis. You can look at temperature. You can look at wind. You can look at dew point, all sorts of parameters on this. And it's a really useful way to see the weather. And I think the critical thing for rural and regional users is that you don't have to rely on the forecast for the nearest big town or city. There's underlying this forecast is a grid. It depending on where you are in the country, it's either a 3 or a 6 kilometre grid. If your farm is in one of those grids, you can click on your farm and the forecast is specific to that location. Like all forecasts, there's a level of uncertainty, but that gives you a pretty good insight as to what's going on at your location. It's, I think, one of the strengths of MetEye. The Australian Water Outlook gives that historical forecast and projected landscape water balance information. Again, you can search for a location over that 5 kilometre grid. Underlying this model is Access S, so it's integrating forecast rainfall with evapotranspiration and information about soil type and drainage rates and things like that to give you a predicted soil moisture at the landscape scale. So this is showing soil moisture at the 30th of June 2024. You can see it's a pretty grim picture in southeast South Australia and Western Victoria. It's picked up a bit since. You can get a sense of where it sits on a catchment scale in a percentile sense. This is showing that at more the soil moisture was sitting at the 31st percentile, so it's under average for that at that particular time. A bit surprised at that because they had a really good season up in the north of New South Wales. My Climate View is another website, a product that's funded out under the Future Drought Fund, and what this does is looks backwards at what various parameters are relevant to the commodity at your location, and then projects forwards using climate models to 2070. Now, I'm not sure what commodity this was looking at, but it's saying there that this chart shows the past and future range in the total number of frost days at flowering at your location. I wouldn't be surprised if it's a cereal cropping commodity. There's 22 separate commodities: cherries, barley, wheat, macadamias, and it enables you to see what's the future going to look like. You can project that average, in this case, of frost days at flowering in this location. You can see that in the purple what the average has been, and you can look at what the median is in the future. So if frost days at flowering is a problem for you, climate change in regard to that aspect of the future is going to be beneficial. It's going to reduce to pretty well 0 frost days at flowering. Of course, that has other issues for other commodities, like, say, cherries that need some cold nights during the course of the year. So this is, if you find My Climate View, again, there's a QR code, but if you find My Climate View online, you can plug in your location and you can plug in the commodities that you're interested in: sheep, cattle, what else, dairies in there. So for something like dairy, one of the particular issues there is temperature humidity index. That's in there, and it'll predict what changes you might see in the temperature humidity index in the years ahead. We also provide this e-learning module. This was a product that came out of a project called Agri-Climate Outlooks. It's probably focused on advisors and agronomists, but it's free to use for anyone. And it's basically an online learning course to give you a bit more detail about how to understand and interpret the forecast along the lines of what we've been covering today, but perhaps in a bit more detail. You'll see up the top there that it focuses on grains, rice and cotton because those were the industry sectors that were the major funders of this product. But the news is that if you're interested in the information that you'll find is quite relevant to livestock producers as well. I want to wish you a Merry Christmas. I'm obliged, I'm told, to provide you with a Christmas Day forecast. So there it is. This is yesterday's forecast, I might say, for Adelaide, Mount Gambier and Port Augusta. So it looks like you're in for a hot one. I hope that this has been of some value to you. I just reiterate, we'd be very pleased for any questions or comments via our agriculture email account. I'll just pop that up again. Say again, not to be shy. We'd be very pleased to hear from you. Thanks once again for participating today, and to Livestock South Australia for hosting me.